So we were solving this problem. The remaining and the left out thing was round robin. So for the same problem, the time quantum it can be like 1 or 2 sometimes. So 2 is usually easy. So I'll go with 1 time quantum for the same thing. It will be a bit lengthy for us because we will have to like make 25 that partition like this 25 boxes for this. So it is also called something. I'm just not able to remember that. So if you see that in the notes, you can use that particular sentence and explain the same thing problem in words, and you can also use that for your definitions or explaining the algorithms in your theory part. So round robin usually it follows first come first serve. So one by one all the processes are like one by one each process will come. So now let us start now. So first what you have to do, you start, right? So just see here, just keep making boxes like this, okay? So 0 1 2. So here quantum equals to 1 I will put, okay, 0 1. So this is 3. First let me write 4 5 6 7 8 9 10 11 12 13, okay, till 14. So here from 14 I will start, okay, 15 16 17 18 19 20 21 22 23 24 25. So now I have to put a line at each place. So actually this 25 thing, so now okay, actually then just ignore that sentence. So now see here, I'll just write this burst time, okay, here for reference 10 5 6 4 it was, I guess, p1 p2 p3 p4. We don't see the arrival time. So now what we do, right? So one by one each process will be sending. It's not like I'll send p1 one by one in everything, no. So first p1 will come, okay, then p2 will go, then p3 and then p4. Then what happens, these values now it will reduce now, okay. So this becomes 9, this becomes 4, this becomes 5, this becomes 3. So likewise p1 goes again, p2 goes again, p3 goes again, p4 goes again. So this becomes 8 3, this becomes 2, this becomes 2, sorry, this becomes 4, this becomes 2. So simply put comma, again all 4 goes, p1 p2 p3 p4. The only hectic part of this round robin is that while calculating wait time, so you have to use this again and again where it was, wait this. So this is a time quantum 1, right? So usually it takes lot of like space and lot of work will be there, right? If you understand this, then if they give time quantum 2, now it will be easy for us to do. So instead of this 1, 2 will be there. So instead of just reducing 1, so 2 burst time. So 2 times burst time is nothing but that milliseconds time taken for that process to execute in that particular time. So instead of directly you can write 0 2 4 6 like that, at the end you will have 24, and then for 24 one only you will put, obviously if you cannot put 26. So what is the remaining, you will put that much, and one bind you will send. So 2 2 will go. Suppose you had what to say here at the beginning, yeah, see you had 5, right? So you will give send p2 here, so you will send p2 here, so that becomes 2 2 itself. At the last only 1 is left for this p2, so you won't give 8 to 10 or like that. I will just explain that part later. So let us focus here now. So as you see here, so 3 times it changed, right? So first after writing this it became this. Now after writing this it became this. Now after writing this it will change to 7, this becomes so one by one it will get reduced, okay. 3, this becomes 1, okay. So see here p4 how many times it come, 1 2 3. So 3 over, so only 1 is left. So again we will send p1 p2, okay. So here p3 p4, make sure I ended here 14, again started from 14 here in the next line. I cannot directly write 15 16 dollars. If you do like that, you will have one this less, one box less, you will go wrong over there, okay. Now you see here this becomes 0 2, this becomes 1, this becomes 6. Now you can see now we won't be using p4 again, so p4 will stop here itself. So only p1 p2 and P3 will be going. Now, so again it becomes reduced. So this becomes 5, 0. This becomes none. Now you see no P2 also. Now only P1 and P2 will, P3 will go. Okay. P1, P3. So this becomes 0 now. Okay. So this becomes so. So now in all the boxes just write P1, 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 P1. So this is how in round robin you write. This is the easiest one actually, because there is no any logic over here. Just the only logic over here which is there. So whatever you have to do, like SJF, some priority condition, or you have shortest of first result, the conditions are not there. The only thing you have is time quantum. Just divide the Gantt chart like this, and then one by one you have to write and reduce. So this you can write in pencil somewhere, or you can just make one box and such that the insulator can know what you have done instead of doing in the rough place. Or also you can do in the rough place. Anyhow, if they see, they'll understand whether you have like done something or not. Okay. So now we will calculate the waiting time. Okay, waiting time. So now just concentrate over this part. P1 is equal to, so what you have to do, so we have arrival time, right? So let me just copy that. So 0335, 0335. Okay, so first initially P1 got chance at 0 and arrival time is 0. Now plus, so P1 has occurred many places, right? So second time it has come here. So 4 minus this next number, it will be there. Okay, 1, because time quantum is 1. Suppose time quantum is 0, instead of 1, 2 would have come, because the next number after 0 according to time quantum. So now what I will do, plus again where P1 has come here, 8 minus one number next to this, it will be okay. I mean one number next to this, see here, 5, plus then again P1 where it has come, 12, 12 minus, so previously where it was, where it ended, that number itself. So that was the logic. So why, how we can get this? Two ways it is. One easy way is, see this Gantt chart, 8 is there, so next here minus, this 9 will be minus. If not, just see here, here 8 was here, that next will be minus, plus, so where again P1 has come here, 16, right? 16 minus, so 12 after 13, it will be same, you shall see here. Then plus, where it came again, 19, okay, 19 minus 17, see here 17, just I saw here, okay, plus last thing, okay, this is last 21 minus 20. Then again I won't write plus this minus, because from here to here it's the same, right? So I won't be writing that. Now again I have to write here, this was 0, plus 4 minus 1 is 3, 8 minus 5 again it is 3, 12 minus 9 is 3 again, plus 16 minus 13 is 3 again, plus 19 minus 17. So you, as you see here, from this also you can understand that wherever we are getting 3 as the sum, till there all 4 processes were there. From here one processor finished the execution part, that's why here only 2 will come. Okay, then at the end directly we have just plus 1. So 3 4s are 12 plus 3, so 3 5s are 15. Once again, if you see me going wrong in any calculation, just do the calculation from your part once. If not, just pause the video and check once for yourself. So now let us do for P2. Okay, so P2, see here, first it got chance at 1. Okay, minus arrival time is 3, plus, so you see where the P2 has got chance again, 5 minus 2, then again you just see where P2 has got chance, so that is 9 minus, it will be 6, okay, plus here 13 minus 10 plus, okay, we have again, so that is at 17 minus 14. Okay, so then again do we have? No, we don't have, so it's nothing but here we get minus 2. Okay, then we have here 5 3 3 3 3, so plus 3 3 3 3, correct, at 5 minus 2 is 3, 9 minus 6 is 3, 30 minus 10 is 3, 17 minus 14 is 3, so 3 3s are 9 plus 1, okay, this will be 10, right. So 12 minus 2 is 10. Now let us do for P3. So P3 here, 2 minus 3 itself, because initially arrival time was 3, right. then where is P3? Again 6 minus 3 plus again where is P3? 10 minus 7 plus P3 where it has come again here 14. Okay, 14 minus 11 plus again P3 has come, yeah, 18 minus 15. Okay, then again P3, yeah, it has come at 20 plus minus 19. Then do we have P3? No, we don't have P3. So 20 minus 19, yeah, correct, yeah, correct. So here we have P3 minus this when it ended. Okay, last when it was here last. So 2 minus 3 here minus 1. Okay, plus 3 3 3 3 at the last we'll have plus 1. Okay, so this cancel, 3 3 is 3 4 the 12. So we'll do for P4. Okay, now it initially got 3 minus 5 plus, so usually I took 2 as a time quantum, right? So sometimes you are getting minus value here, just don't bother that. Getting I don't think whether there should be a minus value or not. So they won't give. So I took one normal question, and from that normal question I am writing everything just for you to understand. So no matter what they give, according to the time quantum, just plot that and make it it should be. So I will do this once again with the time quantum, let us say 3. That should be even more easy for us. So for this 3 time quantum should, so I will do that once again after solving this. Then what do we have? 3 bit has come occurred. So 6 minus 4. Okay, sorry, it is not P3, right? It's P4, 7. Okay, P4 plus where is P4? 11 minus 8. Okay, plus P4 15 minus 12. Okay, then plus where is P4? No, we don't have P4 again, that's it. Okay, equals to minus 2 plus here 3 plus 3 plus 3 so right. 15 minus 12 is 3, 11 minus 8, 9, 10, 11. Okay, so 6, 7. Okay, what you got average if you do 15 plus 10 plus 12 plus 7. So 10, 20, 30, 35, 36, 37, 44. If you do 44 by 4, it is nothing but 11. Turnaround time, how you do? You just add this. Okay, P1, P2, P3, P4. Waiting time plus first time. So waiting time we will write one by one. 15, 10, 12, 7 plus 10, 5, 6, 4 equals to. So this is 25, this is 15, this is 18, this is 11. So which is average if we put is equals to, right, 25 plus 15 plus 18 plus 11. So 44 plus 25, that's your 49, 15, 69. Okay, so sorry, is equals to 69 by 4. Wow, calculator. So in calculator, 69 divided by 4, 17.25. 17.25. As you can see, the time taken here is a lot. Okay, again and again they have to. So round robin is also good. So here everyone will get chance again and again. They won't be bored or starved or aged or something. Some part is also at least being executed. So I'll just draw the Gantt chart if time count was 3. Okay, time quantum if it was 3. Sorry, the part was not visible. At least you heard me. So you can see here, pause and see once. Suppose time quantum was 3. Now let us just see how that Gantt chart will be. 0. Okay, 3, 6, 9. Just 3 tables you have to write and go. What's there in that? 15, 18, 21, 24. Now don't write 27. Just write 25 itself. Okay, so here doing this is not a good idea. If it was 1, it is good. Anyways, let us see now. P1 comes 3. Okay, I'll where shall I do? Okay, I'll write here 10, 5, 6, 4. Okay, so usually this is not, this won't come. I won't consider this. Now here, why I'll say tell that. Now P1 comes 3, so this becomes 7. This should become, so P1 P2, P3, P4. Okay, so here 6, 9 till here it's correct, right? So now see what happens. This becomes 7, this becomes 2, this becomes 3, this becomes only 1. Now if you see again, P1 will come, it will execute for 3 milliseconds because time constant is 3, and it will go, it will be preempted. Now P2 comes. Now P2 only 2 is required, na? So instead of 15, here see here 18 was, no, it won't be 18, it only 2 is there, 17, only required is 2. So this becomes 5, sorry, this becomes 4, this becomes 0. Now this one is only 3, P3. So here 20 will come. Okay, now P4 it is only 1. So P4 if you put, it is only this 21 will come. So see here how this thing changed. Okay, then you have only remaining thing which is left, 0 ho gaya, 0 ho gaya, so 4. So you put like this, P1 write 24, then you do again write P1, then you write 25. Suppose time quantum was 3, this is how you do. If it was 2, same way you will just one by one write and go. Okay, only if it is 1, write off like this, the previous way I did. For 2 you don't do, because sometimes what happened, the odd numbers are there, right? If odd numbers are there, it will get stopped. If odd numbers are there and your time quantum is even, so only at the end only one bus time will be remaining. So if you write 2 2 2 and go, so there you will make mistake and you won't get. And see, so for every question we got 25 at the last. You have to get that. As you can see here, for FCFS, SJF, and this priority, for primitive, non-primitive, everything, the end thing was 25. So just make sure whenever you get questions for this, for all the types of algorithms they ask, the end whatever is, that should be this itself. Whatever if you add all the bus time, whatever you get by adding the bus time, that should come here. Okay, so that's all. So the table for this, just let me do. So one by one I'll write first what I did. So okay, we did FCFS, then we did SJF. Under that I'll just add IN to here, preemptive, non preemptive. Then I'll write priority, we did, right? Under that again I. Okay, preemptive, then non, I will put like this. Then what we did, round robin, usually it's denoted by RI. These algorithms, okay, here waiting time for each, and here turnaround time. Okay, so let me just see and write one by one. So this is 8.75 milliseconds and this is 15 milliseconds. Even if they ask or not, it's better to do this. Okay, so SJF primitive, this is 75 milliseconds, this is 13. So non preemptive mein how what we have, average is 8 and 14.25, 8 milliseconds, here 14.25. Then let us see priority ka 6.25, 12.5, 6.25, 12.5. Then preemptive priority ka 8.5, 14.75. Then round robin, what we get if time quantum is, what did we get, 1, it's very high here if time quantum is 1. So it is 11 and here it is 17.25. I suppose the time quantum was this 3, right? Just calculate that. There shouldn't be much, it will reduce. Okay, if time quantum was 1, this will reduce. Now you just make table like this. Now see here, according to this C, which has the least bus time and waiting time and turn on time, which has got the least waiting time. Once again, just check the values by solving yourself. Once you solve itself, you will understand how to do. If now in few minutes or in few moments exam is it, then just see and go what's there in that. So priority primitive, now see here, that has the least, I guess. So 6.25 and 12.5 milliseconds. Don't write. Just write like this, and this algorithm is has the least waiting time and average turnaround time, and finish the problem. That's it. You have to do for all your this scheduling algorithms. There another this scheduling multi-level feedback like that. In that nothing what you have to do. So usually there is one this box type thing diagram. Just remember this diagram for that. They have done 3D diagram. How to do make 3D? Just add one line, add like this. I messed it up here. Not a problem. It should come like this. Okay. this will go like this will go like this, here, 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 or else first make one box properly, then one line like this you do over, from there straight, ding ding. So from this what happens, this goes here, again like this, and goes like this. It's confusing, this diagram. Just here time quantum will be 8, here will be 16, here will be first come first. So sometimes what happens, multiple. So here instead of one algorithm you use more than one algorithm. Okay, so here sometimes what happen, if the job whatever it is coming, if it can be executed in this time quantum, it will be executed and will just go out. If not, it will send here. Okay, it will be sent here. If it is still needs more, then it will be sent here. So which comes first, that will be served completely at the time, and then that will go out. I don't know whether, I think there should be one line like this. Suppose that finishes, then it will go out, right, or else it will go there. So this thing, just understood the diagram, right? So whatever the processes are coming, if in the within this time quantum, if it can complete its execution, it will go out. If not, then or else it will be passed here, because you don't have to like make them be waiting here, make them wait over here. So you will send them here, even still if they have like it's taking more time, just send here. So that's how, like in different level you have set your algorithms and perform. So everything is over. From all these algorithms, so how we have solved, we can just convert them into theory part. Just see the keywords, okay, wherever that from CPU, whatever they call for it. Instead of bus time, CPU bus they say, okay, bus time, instead of bus time they say CPU bus is this much, computer processor, like that, some words, and just finish your theory part. It covers your half of the module from second module.